With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So here we have a question. We have to evaluate limit a tending to pi by 2 negative 0 to a cos x ln cos x dx. Okay. So here you can clearly see that I can apply here by parts. We can apply integration by parts, and we have two functions in product and we have to integrate that thing. So if we have, let's suppose u and v two functions in product, then the integration will be given by, let's suppose this is my first function, this is my second function, then the integration will be first function as it is integration of second function with respect to x minus differentiation of first function with respect to x, integration of second function with respect to x, and then integration of the complete thing. Okay, so this is the simple formula for the by parts. I'm going to apply the by parts here. I'm going to assume my I is equals to integration 0 to a cos x ln cos x dx. Okay, but the big question is which function is first function and which function is second function. So basically the function which you know the integration directly, assume that function as the second function. So I know the integration of cos x, that's why I'm assuming it as second function, and thus that ln cos x is my first function. I'm going to integrate that thing. It will be I equals to cos x as it is, sorry, ln cos x as it is, integration of cos x, okay, dx, and minus differentiation of ln cos x with respect to x, integration of cos x dx, and here we have dx complete integration 0 to a, and here we have 0 to a. Okay, now I'm going to integrate this thing, so it will be I equals to ln cos x into sin x. As we all know, the integration of cos x is sin x, limit 0 to a, okay, minus here I'm going to differentiate this thing, so ln cos x differentiation will be 1 upon cos x, and the cos x differentiation will be minus of sin x, and the integration of cos x is sin x. Here we have dx, and here we have integration from 0 to a. Okay, now I'm going to solve this thing more, so it will be I equals to, I'm going to apply the limit here, so it will be sin a ln cos a minus sin 0 ln cos 0. Okay, so this is the upper limit minus lower limit. Hope you already know how to apply the limit in the definite integration. Minus this minus minus become plus, and here I can write 0 to a sin square x over cos x dx. Okay, now I'm going, for solving this thing, I'm going to add 1 and subtract 1, okay, in the numerator. So why I'm doing this thing, let me show you. First I'm solving this thing, so it will be I is equals to sin a ln cos a, and this will become 0 because sin 0 is 0, so it will completely 0, plus here limit 0 to a, I'm taking minus common from here, so it will be minus of 1 minus sin square x, okay, and here I can write 1, and here I'm writing dx, here I'm writing dx over cos x 0 to a, and here we have cos x. I just split this numerator to the denominator. Okay, now moving further, I'm going to solve this thing. I'm going to integrate this thing. Basically it will be sin a ln cos a plus integration 0 to a minus, I'm taking outside, it will be cos square x over cos x dx plus integration 0 to a sec x dx, because here we know that the reciprocal of the cos x is nothing but sec x. Okay, so I'm going to write the integration of this thing, so it will be sin a ln cos a as it is, and here I'm going to cancel out this cos with this cos square. Okay, we will left with cos, and cos integration is my sine, we all know that, and I'm going to apply limit 0 to a, and here we have plus sec x integration is nothing but ln mod sec x plus 10x This is the integration of sec x, we know directly, and the limit is 0 to a. Understood? Now I'm going to apply the limits here. So it will be equals to sine a ln cos a minus sine a. On putting 0, it will be 0 plus ln sec a plus 10a. On putting 0, sec 0 is nothing but 1, and 10 0 is my 0. Okay, so I'm writing here it is ln 1 only. Okay, and ln 1 is 0. Hope you already know. Now I'm writing this thing. It will be I equals to sine a ln cos a minus sine a plus ln sec a plus 10a minus 0. Okay, because ln 1 is 0. Okay, now as the question said, we have to apply the limit a tending to pi by 2 here. Okay, so I'm going to apply the limit. So it will be limit a tending to pi by 2. It will be sine a ln cos a minus limit a tending to pi by 2 sine a plus limit a tending to pi by 2 ln sec a plus 10a, as it is a. Okay, now I'm going to solve this a little. This is the given thing, which is this. Okay, this is what we have to evaluate. Now I'm writing it again. It is limit a tending to pi by 2 sine a ln cos a minus, I'm solving this thing. On putting pi by 2 here, sine pi by 2 is nothing but 1, so it will be completely 1 plus, I'm solving this ln in sine and cos terms. It will be limit a tending to pi by 2 ln 1 plus sine a over cos a. I just wrote this 1 over, this as 1 over cos a, and this as sine a over cos a, and on taking LCM I will get this thing. Okay, now moving further, if I apply the limit here, limit pi by 2 here, okay, this is sine, so it will be sine pi by 2 is 1 and cos pi by 2 is 0. ln 0 is my indeterminate term. That's why I'm not applying the limit here. I'm writing it as it is, limit a tending to pi by 2 sine a ln cos a minus 1 plus limit a tending to pi by 2 ln, I'm writing this thing as 1 plus sine a minus ln cos a, because by the property of log, which is nothing but ln a by b can be given by ln a minus ln b. Okay, I just used this property here. Okay, now moving further, I'm going to take common this ln cos a from here and here. I will get, see carefully, I will get limit a tending to pi by 2 sine a minus 1 ln cos a, and the remaining things as it is, minus 1 plus limit a tending to pi by 2, it is ln 1 plus sine a. Okay, now if you put the limit here pi by 2, so you will get, on putting pi by 2 here, it will be 1 minus 1 is 0 into, here we have ln cos a, and on putting a as pi by 2, it will be cos 90 is 0, so that's why it will be ln 0 is infinity. So infinity into 0, it is my indeterminate term, so that's why we have to solve this by L'Hopital rule. I'm going to apply L'Hopital rule here. So L'Hopital rule says that when we have indeterminate term, then differentiate the numerator and differentiate the denominator individually and then apply the limits. But here we don't have any numerator and denominator. That's why I'm going to make the denominator here. So I'm writing this thing as sine a minus 1 over 1 over ln cos A. I can write this thing. Okay, hope you understood this point. Okay, I'm solving this part only. Okay, so it will be this, and now I'm going to differentiate in numerator and denominator separately. It will be limit a tending to pi by 2. Sin A differentiation is cos A, and minus 1 differentiation is 0 over, here we have 1 over ln cos A. So it will be 1 over something, means it will be minus of 1 over ln cos A to the square. Then ln cos A will be cos A minus sin A. Okay, because ln differentiation is, we all know, 1 upon x, and then x differentiation is this. Okay, so this is the complete differentiation. Now I'm going to solve this thing. It will look like limit a tending to pi by 2 cos A, and this cos A will multiply here, it will be cos square A, and this minus minus become plus over sin A over ln cos A to the square, and I'm taking this thing here, so it will be ln cos A to the square. Now if you try to put the limit here, you will again get infinity over something like that value. Okay, basically you can write this cos as secant. Okay, I'm writing it as limit a tending to pi by 2 ln cos A raised to the power 2 over sin A sec square A. Here I'm going to apply the limit a tending to pi by 2. So ln cos pi by 2, it is infinity, and infinity square is infinity, over sin pi by 2, it is 1, sec square pi by 2, it is infinity. So infinity over infinity is basically indeterminate term. That's why we have to apply L'Hopital rule again. So here I'm putting the limit in sin, and other things I'm going to apply the L'Hopital rule. So it will be, I'm going to apply L'Hopital rule, so it will be 2 ln cos A into, then ln cos A differentiation, it is nothing but over cos A, then cos A differentiation is minus sin A. Okay, over sin pi by 2 is 1 into secant square A. Now the definition of sec square A, it is 2 sec A into sec A 10 A. Okay, now I'm going to simplify this thing, so it will be limit a tending to pi by 2, this 2 will cancel out this 2, it will be ln cos A, minus I'm taking outside, and here we have 10 A because sin over cos is 10A. Okay, over, it will be sec square A 10A. 10A will cancel out 10A, it will be minus of ln cos A by secant square A limit a tending to pi by 2. If you apply the limit now, it will be minus of infinity, because cos pi by 2 is 0, ln 0 is infinity, over sec pi by 2, it is also infinity, so it is infinity over infinity, which is my indeterminate term. Okay, so I'm applying again L'Hopital rule, and I guess it is the final time. Okay, so it is limit a tending to pi by 2, here it is minus of cos A, okay, cos A, and cos A differentiation is sin A. Okay, over the differentiation of sec square A, it is 2 sec A, then sec A 10 A. Understood? Now moving further, I'm going to simplify this thing. It will be limit a tending to pi by 2, and this will plus, okay, minus minus become plus 10A over 2 sec square A 10A. Okay, 10A will cancel 10A. Okay, and I will left with limit, I'm writing here, limit a tending to pi by 2, 1 over 2 sec square A, and sec square pi by 2. it is nothing but infinity. So it will be 2 into infinity, it is infinity. So 1 over infinity is 0. So finally the limit is 0. Okay. So this complete thing having the limit 0. Okay. This thing having the limit 0. This is minus 1 already. And I'm going to apply the limit here. It is ln 1 plus sin a. I'm writing here. So it will be 0 minus 1 plus limit a tending to pi by 2. Okay. Sin a, and let me see here, it is plus 1. Okay. ln sin a plus 1. I'm going to put the pi by 2 here, so it will be minus 1 plus, on putting pi by 2 it is 1, it is 2. Okay, ln 2, and the final answer is ln 2 minus 1. So this must be the final answer for this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.